Now we're going to take a look at problem 4 and 5, starting with problem 4. On problem 4, we want to find the average of 6.2 right here and 7.3 right there. So the obvious thing is to add them together and divide by 2, but that's not how it works because you've got 75% of your atom sample is 7.3. 25% of it is 6.2. So if I want to average those two numbers, I've got to say, pretend I've got 100 grams of each one. So if I had, or 100 atoms of each one. So if I had 100 atoms, what's 25% of 100? It'd be 25 atoms. So you're going to assume 100 atom sample. So 25 atoms, okay, multiplied by 6.2 AMUs, okay. And then I've got how many atoms do I have that weighs 7.3? Would be 75 out of my atoms would be 7.3, so 75 times 7.3. Okay, so I'd end up with whatever 25 times 6.2 is. That is not what it is. So 25 times 6.2 equals 155. So over here I'd have 155 plus 75 times 7.3. So 75 times 7.3, and I get 547.5. So now if I add those together, 155 and 547.5, there's two right here. I get 702.5. So what would I need to divide by? Would I divide by 2, or would I divide by the size of my sample, which was how many atoms? 100 atom sample. So I divide by 100. Divide by 100 means it's going to end up being 7.025 or 7.0 if I pay attention to significant figures, because that is accurate to the tenths place. So 7.0 would be my average weight. All right, so I'd expect you to know how to do that. If you didn't want to have to divide by 100 at the end, you could just use 0.25 here and 0.75 there. And then you wouldn't divide by 100 at the end. Okay, so that was that problem. Now the next one, a little harder. I'm going to do this. I'm not going to put one like this on the test, but basically you've got the same situation, except this time you know the two weights and you don't know the percentages, and you're trying to find the percentages. So I'm going to set it up where some percentage times 22.2, so I'm going to call it y times 22.2, where y is the percentage that has that mass. And then I'm going to put in x times 24.3, where x is a percentage that has that mass. And we know the average is 24.1. We also know that whatever y is and whatever x is, it'll equal 1. All right, now I'm using here what's called a ratio form. So I'm using a decimal form of percentages. So I'm not using the actual percent. I'm using 0.75 instead of 75%. In other words, I've divided by 100 before I started. Okay, so this is an equation that you've used in math before. So you know 22.2 goes here, 22.2 goes there, 22.2 goes there. So you're going to multiply everything by 22.2 so that you can cancel out your unwanted variable. Okay, so this is all gone. To subtract the equation, you're going to end up with 3 minus 2 is 1. So 2, that was 22.2, 24.3. We multiply by 22.2. Okay, so 22.2, so that would be 3 minus 2 is 1, 4 minus 2 is 2, so it would be 2.1 x equals, and then 11 minus 2 is 9, 3 minus 2 is 1, and 0, so equals 1.9. So x is equal to are you going to divide both sides by 1.9 or divide both sides by 2.1? Once again, that's a really common mistake. So you divide both sides by the number with the variable. So 1.9 will be divided by 2.1. You end up with 90%, or 0.904. So x equals 0.904, which means that 90.4% of the sample was x. And that means that 9.6% was y. So 100 minus 90.4 is 9.6. Now, does that make sense with what we know earlier? We know that you had two isotopes, that weight and that weight. But the average was closer to which one of those? And that's what I defined as x. That particular isotope I defined as x. So, you look, excuse me. So there you go, that's x. So x would be 90% makes sense because the average is very close to that number. All right, the other way you could have set that up, I'm going to set up right here. If you wanted to, you could use y is 22.2. So y multiplied by 22.2 plus 1 minus y times 24.3. So we'd be defining the percentage of the 22.2 as y and 1 minus y as 24.3. And that would equal 24.1 you could solve. So this one's called using a system of simultaneous equations. This one's using a solving by substitution. Either way, you'll get these two percentages. All right, so I'm going to stop there with movie 2.